Hello my friends, welcome to a learning session where we are going to build one of our first generative AI applications with YugabyteDB. Our application is going to use two components in addition to YugabyteDB. The first one is the pgvector extension. That's an extension that was created for Postgres so that you can use the database for the generative AI apps and other type of applications. And second one is the OpenAI embedding API. OpenAI is the company who created ChatGPT. Right? Some of us use ChatGPT daily, but also you can have access as a developer to the models of the OpenAI. And we are going to see how to use YugabyteDB, pgvector, and OpenAI APIs to build our first GenAI application. So the application is going to look as follows. Let's say that you have users who are traveling to San Francisco, and they would like to get recommendations about the places where they can stay. So generally the user will connect to the React frontend and will type a prompt, and then that prompt will be taken and sent to the Node.js backend. And the backend supports two modes. The first mode is the OpenAI Chat mode. And in that mode, the prompt will be sent to the OpenAI API as is without any changes. And then we will be waiting while the AI generates some recommendations for the user. As you will see, this mode is not that fast, and we would need to optimize it. We would need to boost it. For that, we will support the second mode called Postgres embeddings mode in this application. And with that, we still are going to use the OpenAI embedding API. We will take the user prompt and we will use the OpenAI API to generate an embedding, a vectorized representation of the prompt for the user. And then in our YugabyteDB database, we are going to use the pgvector extension to store a vectorized representation for the Airbnb properties. And effectively, we will be comparing the user prompts embedding against the embeddings for our Airbnb descriptions. And this is how you will get recommendations. And you will see how performance is going to be improved. All right. So that's a high level architecture. So now let's code a little bit. All right, this is the source code for our application. By default, we are going to connect to Postgres, but we need to change that. We want to connect to the YugabyteDB, and I have a YugabyteDB instance running on my laptop. This is a 3-node cluster. We will take a look at it later. Just for the records, let's update this properties file. Next, the backend and the frontend. The frontend is just React app, nothing interesting. The backend has the following API endpoint, REST endpoint. You need to trigger the search method, search get request, and then pass the prompt, the user prompt from the React. This is what the React does. And then also the React selects the mode or the engine. So their backend supports, as we discussed, two modes or two engines. The first one is the Postgres service when we are using the pgvector API, in addition to the OpenAI embeddings API. And the simplest one is their OpenAI chat completion mode. And this one is already implemented, and this one is used by default. Let's take a look at it. So generally, we will take this user prompt, and then we will use this OpenAI chat completions create function to send the request to their AI that is deployed somewhere in the clouds. And as you remember, we usually need to, when you use ChatGPT, you need to share some context, what exactly you want to get from the chat. You just need to define your expectations. And also in the source code, we are defining these expectations by providing the system message first. The system message is not visible to the user. And the system message says that you're a helpful assistant that helps folks to find properties in San Francisco. At least suggest 3 options, and please return the response in the JSON format. Why in the JSON format? Because our front end expects the JSON data that will be displayed on the interface. And after the system message, we are passing the user message, and the user message will be carrying the prompt, the user prompt. Finally, we will get this response. Every chat completion has choices, and we will convert the message, the content of the choice, to the JSON. It will include the places, and then those places will be displayed on the screen. So let's take a look how it works. For that, we need to start the backend and the front end. That's a live coding session, so folks, something might fail. It might not be perfect. Similarly, when we develop anything from scratch. All right, so that's our OpenAI lodging service that gives recommendations for those who travel to San Francisco. And this is the OpenAI chat mode. The Postgres embeddings mode is not implemented. So let's say that, okay, we know that we already traveled to San Francisco. We can say that I'd like to stay near the Golden Gate Bridge, let's say in a walkable distance to coffee shop. All right, something like that. Something went wrong. Okay, let's check the logs of the backend. Okay, I forgot to pass the model parameter. That's very important. So thanks for reminding me. How do we fix it? Really easy. So in your chat completions request, what you need to do after the messages, at least you need to pass the model. And which one are we going to use? GPT, yep, GPT-4, the latest model. But the downside is that you need to restart the backend. Let's restart this backend. Once the backend is restarted, we can send this one more time. And now you can see this Pac-Man is eating, which means that we have sent the request and the request is being processed by the GPT-4 model, and it takes time. Just you try to count. Probably it will take 10 or 15 seconds, if not more. And this time is enough for you just to go and just drink a cup of, water. All right, but finally we've got some recommendations, and that's excellent. Yeah, some places near the Fisherman Wharf, Golden Gate Bridge, and here you've got the price. So wonderful. And this is the JSON, that what was generated by the OpenAI. But what I don't like is the latency, the performance, and I cannot launch the application in the following way. And this is where the pgvector becomes useful, and this is where you start thinking about vectorized databases. But Postgres as a relational database historically supports the vectorized data. It can store those embeddings in your database, and you can create powerful applications. Today we are going to use YugabyteDB. Where is my YugabyteDB? Let's take a look at YugabyteDB. So I have YugabyteDB running locally. This is my 3-node cluster. Nodes, yep. Do I have any tables? Yeah, I have already some table, but we will build from scratch because I'm building from scratch. As you remember, I already have this table, but I will drop it. We don't need it. We want to do this from the very beginning. All right, no tables. Where did I get this table? I googled, I found a sample Airbnb dataset on the internet, and this one is a perfect match for our application. So you will find it in the repository. So it's here. They have 107 columns, like this table is very large. So let's create it. Here, as you can see, that's our table. Wonderful, all is ready. So what the table has this description column. And the description column is very informative. So here it is. It describes in details what can you expect from this property, like size, different amenities, location, etc. And this field is a perfect fit for our similarity search or for our generative AI application. But right now the data set is empty. I need to load the data. To do that, yeah, I have this command somewhere because I don't remember it. I don't try to memorize all the command, folks. It's already on my file system, and it was quick. We've got actually the data set. It's a pretty good data set. We've got 7,575 properties that are available and listed on Airbnb for San Francisco. And right now, if you do the select, let's say property name and description from Airbnb listing, let's do 2. You'll see this. Yeah, it's hard to read this. Let's switch to this display mode. It's gonna be much better. Yeah, let's say that's our first record, and we have some upscale luxury queen, probably property, and that's the description. That's the second record. So this description is well enough, and I think that it will be easy to use it as our column. Like for these descriptions, we will generate embeddings, vectorized representations, and we will store them in YugabyteDB. For that, we need to do several things. First, let's enable the pgvector extension, create extension vector. Already exists, which means that I have already created it. Wonderful. Next, and we want to alter this table. We need to add the embeddings column for the descriptions. So we need to alter table Airbnb listing, add column. Let's give a name as description embedding. The type is going to be vector. And the size is 1536. This is 1536 dimensional vector. This is how OpenAI model generates it. If you use other models, the size of the vector can be different. Okay, so now we've got this column added, and we need to generate. How do you generate? Let's do this. We can implement this from scratch, or you might use the data set that already has all the data. Here is my source code. This is the loader. it will connect to the database, and that's it. And then it expects us to write what needs to be done. Okay, so let's do this. We are connecting, but our query will be different. We want to get the ID and description from Airbnb listing. So we will get this, and then we know that the result will carry rows. So we will take result rows. For each row, we want to do this. First, we want to use the OpenAI embeddings API to generate an embedding for every description. Okay, so let's do this. Const embedding response. And we also need to wait. Yeah, embeddings create. Thanks for the help. We need to use OpenAI, let's say, embedding model. So that's the model, and here is your row description. But also, the OpenAI API suggests you to replace new line characters in your descriptions with spaces, and we can also replace some other characters that you don't want to be used by the model. For that, I have this regex does exactly what we want. We will get those embeddings back, and we want to update them. Okay, so how do we update them? Easy. We are going to run another request, await client query. Yes, we are updating Airbnb listing, but our column name is description embedding, and the ID, yeah, wonderful. So the parameters need to be adjusted because this is GitHub Copilot, and it probably doesn't know the latest API. But this is what we need to do. We update it, and then let's have some counter in here. We have counter, and the counter is set to 0. And then you can do this, increment this counter, and let's type to the console the result. Updated counter rows, okay? Let's start it. Okay, creating another session. Let's go to the backend, and here we have this node generator, starting it. Okay, so generally looks like I need to fix this await. Anyway, I think that it doesn't like that we execute it within this block. This way, it's like an anonymous function. Let's try to update our implementation really quick. So we will get, let's do this rows, and we have result rows, and this one we will change to the following. For e while less than row length, we are going to get let row equal to row e. Okay, so now it should be fixed, and we don't need this. All right, so now it should work. Checking. Vector contents must start with. Okay, I know what's happening. This is a requirement for the pgvector extension. You need to pass your data this way, pgvector. All right, it will take some time to generate all the data, right? So right now, I can take a pause and I can go and brew a cup of coffee. And I'll probably see you in a few minutes. All right, I'm back. Here is my cup of coffee. I still keep drinking, but nevertheless, the data was generated. Let's take a look at what we have in the database. Let's select description and description embedding column from Airbnb listing. And let's take a look at least at one. So here you have these numbers, like this is the vector, this is the embedding that was generated by OpenAI. You'll see that it's a large vector. And here is this vector was generated for this description. Wonderful. And this step is done. So right now, what we want to do, we want to take the user prompt, we want to generate a comparable embedding to the user prompt, and then we are going to do the similarity search within YugabyteDB, all right? And you'll see how the performance will be improved. Let's open this file, Postgres embedding service. The implementation is empty, and this is what we're going to address. So we have the places, and we need to populate these places with suggestions from YugabyteDB. But first, let's do a call to the embeddings API again, embedding response. Yeah, this is what we want to do, because we are getting the text, the raw text from the user, and we need to generate it to the embeddings Once this is done, we are going to do the similarity search. We are going to find Airbnb properties that are related to the prompt of the user. For that, let's get the result. And we are going to do this request. Yes, we are querying the name. No, we don't need the ID. We need the description of the property. We need the price of the property. And we also want to return the similarity, how similar the user prompt is to the suggested Airbnb place. How do you calculate this similarity? It's very easy. First, you need to calculate the distance between the vectors. We have this description embedding vector, and we are going to use the cosine distance between this one and our user embedding. The cosine distance is the angle between two vectors. And we need to, if you want to get the similarity, you need to subtract this distance from 1 and you will get the similarity. So we will return the similarity. We are getting from the Airbnb listings where the similarity is bigger than our matching threshold, and the matching threshold is going to be passed at the second parameter. And then certainly we want to order by similarity, and the limit is the third parameter, the matching count. Okay, so now we need to get those. So this is how we get in the recommendations. And then for all of those rows, we want to generate places. We want to add an element to our places array, the name, the description, the price, and also that we have the similarity, just so that we know like how similar it is. And looks like that's it. Wow, wonderful. Let's restart the backend. We connected, and finally, let's get to our application. That was our initial prompt. Let's get to the Postgres embeddings. Let's do the search. Okay, we've got something from YugabyteDB. Tremendous. And compare the latency. Let's find some other prompt. So if you do this search, it's almost instantaneous when you're getting these places, and this is the similarity. And compare their latency. If you do the search using the OpenAI Chat Completions API, it will take time. Start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. I'm giving up. Anyway, soon it should be done. We actually get some recommendations, and the latency is unpredictable because it all depends who else is using the OpenAI service, but you don't want to wait. And if you run the same request across our database, it's just less than a second. Job done. So this is how you use YugabyteDB to build scalable generative AI applications using the pgvector extension and the OpenAI embeddings. Stay tuned for more videos. Bye bye now.